today we are going to discuss about motion along a straight line. It is a basic topic of physics, and it's very interesting. So let's begin. In motion along a straight line, we generally talk about particles. Means we talk about the motion along a straight line of a particle. So the question arises in mind that what is a particle? So a particle is a point-like object. Okay. So when I say particle, it is a point-like object. So another question is that what is a point-like object? So a point-like object is an object whose the distance covered by the object is very large in comparison to the size of the object. Okay. So the distance, it is a particle, imagine it is a particle. It is a point-like object and it covers this distance. So this distance covered by the object is very large in comparison to the size of the particle. This is the size of the particle. Okay. So even a car can be considered as a particle because it can also be a point-like object because if the car covers a long distance, means the distance it covers is very large in comparison to the size of the car, then car can also be a particle or a point-like object. So now we are clear about what is a particle. So next we will discuss about position and displacement. Okay, we'll discuss about position and displacement. So position is nothing but where a particle is located. Okay, so position is where a particle is located, and for finding where a particle is located, we have to define an origin. Means with reference to this point, the particle is located at that point. So that is the origin. So we have to define an origin. So if this is the origin, okay. In physics, you can assume the direct. We have two directions in motion along a straight line. That is, one is positive direction and other is negative direction. Okay, positive direction and negative direction. We can assume any side to be positive direction. Like we can assume right side this direction to be positive. Generally we do that. And left direction means this direction to be negative. This is the negative direction. Okay. So this is the negative direction. Okay. And this is the positive direction. We generally do it, but means the right side is positive and left side is negative. But it is not a hard and fast rule to do that. You can also assume the means right side to be negative and left side to be positive. Just negative and positive are just uh, some values to show the direction in which direction a particle is moving. Because in physics, direction is very important. In which direction it moves, to give the information about that thing is very important. So we define two directions, that is the positive direction and the negative direction, and we choose, it is our choice to, we can also define when we will be talking about a falling object, like when we drop a stone from a means very high building, then also we will discuss, we can consider the upward direction as positive and downward direction as negative, or also you can assume upward to be negative, and it can be opposite also. So it depends on your choice and the question. Okay. So uh, so if we will say that a particle is located at x equal to 5, if I say that particle is located at x equal to 5 meters, so what is the meaning of this? So we will define an origin, this origin, and we will assume that particle is located in this point. Okay, this distance is 5 meter, and it is the particle is located here. Okay, we can assume that. And as it is positive, so it is located in this direction. Means in this, if I say that it is located at x equal to -5, then I will say that it is located here in the left of the origin, because negative means left side, because I have assumed that negative means left side, so it will be located here -5 meter. Okay, it is the left side of the origin. Similarly, for up and down direction also we can do that. Okay, so we have now clear with what is the meaning of position of a particle. So next we will go to displacement of a particle. So we will discuss about displacement. Okay. So displacement is nothing but the change in position. Like if a particle is at x1, if a particle is at x1 and it moves to x2. Okay. So this is the displacement, means the change in position. Like it is written as delta x. Okay. It is delta means the change, means final position minus initial position. This delta means change. Okay. So it is equal to final position minus initial position. It's very simple actually. There is nothing in it. Uh, so and uh, one thing you have to remember about displacement is that you have to specify the direction along with the distance. Means what is the length it covered, and length means what final position minus initial position. What is the final position and initial position, and there you can get the what is the means sign of it, and the sign represents the direction. In physics, the sign represents the direction. Okay, so let us assume there is a assume that it is a small question. You can take it as question that if a particle moves from x1 equal to 5 meter 5 meter to x2 equal to 9 meter, then what is the displacement? This is the initial position. This is the final position. Okay. So you may pause the video. It is a very simple question. Just think about the answer. Okay. So the answer is, we know that displacement is the change in position. That is the final position minus initial position. So it will be 9 meter minus 5 meter, which is equal to 4 meter. It is positive. That means that if this is the origin, we have defined the right side as positive. So the particle was initially here at x equal to 5 meter. The particle was here, and what it did is that traveled it traveled this distance, and it went to x equal to 9 meter. Sorry, means this length it traveled, and it went came to the x equal to 9 meter. So as you can see that the direction in which it travels, the direction in which it travels is this side. Okay, it is the right side. It is pointing to the right side. So it is, so that means that the displacement is towards the right, and that is the reason it is written +4. Okay. So like this you can know that what is the direction and as well as the length this arrow's direction as well as length will give you the total displacement. For displacement, you always have to specify the sign plus or minus, that is the direction, because without I have actually not told about vector and scalar quantities, but let me tell you that a vector quantity is something which has means magnitude as well as direction. Okay, means if I say he went 5 meter towards east in the east direction. So this has also a length, means also a magnitude, and also it has a direction. Okay, that is east. So that is a vector quantity. A vector quantity is something which has direction as well as magnitude. And it follows the rules of vector algebra. We will discuss later about it. So just remember that displacement is a vector quantity. That means that it has a direction as well as it has a magnitude. Okay, both thing it has. So always you have to specify in which direction a body has covered that length. If you tell that it is 4 meter, that 4 meter is not a displacement. You have to tell that it is plus 4 meter. That means 4 meter towards the right or east or west. Like that you have to specify. Otherwise, it has no meaning in physics. It is not the displacement. Okay. So so another question is, another example is a simple question. If a particle moves from x1 equal to 8, 8, it is the initial position, and x2 equal to 5, that is the final position. So what is the displacement? Okay, it's a very simple question. Just pause the video and think about the answer. So here the answer is, it is 5 meter. There is the final position minus initial position, that is 5 meter minus 8 meter, that is equal to minus 3 meter. So what is the meaning of this minus sign, this negative sign that we have got? That means, as we have defined this direction, that is the right side as positive and the left side as negative. Okay, so that means if the origin is here, this is the origin, and we are saying that it is at x equal to 8 meter. So initially the particle was here, is x equal to 8 meter. Then that particle, what it did is that it went to x equal to 5 meter. So see that this arrow, if I take this, so the particle was initially here and it went to x equal to 5 meter. So you can see that the direction in which the particle is going is towards the left. The particle is going like this, towards the left. So that is why, as the particle is going towards the left, so the sign of the displacement is negative. That is, as we have represented, the left side is negative, so the particle has a negative displacement. That is, it is moving towards the left, and the 3 represent that it has covered 3 meters towards the left. The total meaning of the means, if we will say it in words, if we will say that the particle has moved 3 meters towards the left direction, or towards, you can say that it is moved to the left direction. So by this is the way we represent displacement in physics. and it will be very useful to you when you go when you learn more about the things means kinematics and all. So let's move to another topic. So now we will learn about average velocity and average speed. Okay. So before learning this, we have to know what is distance and what is displacement. Okay. So if a particle tra- journeys like this, okay, I will give you a question about that, but let us think. Then this whole path length is the distance it covered. Okay, but this area, but as I defined displacement, it is the final position minus the initial position. Means this is the displacement of the particle. Okay, this is the displacement of the particle. But this whole path, the distance is the distance. Means all the path it has covered, the path length is the distance, and the final position minus initial position is the displacement. That is the means where it is displaced. Like you can think like that if to remember that how much it displaced from the initial position. That is the displacement. But total journey, the sum of all the whole path length it covered is the distance. Okay, so this is important to know this the difference between displacement and distance to um, to learn about average velocity and average speed. So that's why I told you. So let us know about average velocity. So average velocity is displacement by time. Simple. This is the average velocity. Okay, average velocity. So as we know that displacement is final position minus initial position. Initial position. Okay. So next we will learn about average speed. We will learn about average speed. So it is distance by time. Okay. So I have told you what is distance, what is displacement. So you can know that what is the average. So now to be very clear about it, we will do a problem. So this is, imagine that this is the origin. Okay, a particle was at x equal to -1. Hence here a particle was there. Okay, and what it did, it traveled this like this straight to x equal to 4. This is 4 meter. Okay, then it went backwards like this. It is the same along the same straight line it went, and it went to like this. It went to x equal to -3. -3 meter means here it is the final position of the particle. So you have to tell me it went here. So you have to tell me that what is the velocity? What is the velocity? And what is the speed of the particle? Or average over. So you may pause the video and think, and then see the solution. Okay. So the answer is, see, it is very simple. That we know that displacement is final position minus initial position. So final position is -3, initial position is -1. So it will be equal to, I'm sorry, I forgot to give the time. You can take time equal to t, or um, you can take time equal to 10 seconds. Okay. Or t also, it is okay. If you have taken t as time or any other time, then it's okay. What is the concept is important. So this is the final position minus initial position. So it is equal to -2, and the time interval t or 10, whatever it is, so it is by t meter per second. Okay, this is the total displacement per time. What is the significance of this minus sign given here? Okay, so the minus signs means we have taken left side as this as negative direction and this is positive direction. So you can see that the particle was initially here. Okay, the particle was here and it went, and finally it was here. So what? So the displacement is in this direction. That is the left side. This is the negative direction. That is why the velocity, the average velocity is also along that direction. That is the left. So that is the significance of this minus sign. Okay. So that is the significance of this minus sign. This minus sign shows that the particle uh, went in the leftward direction or in the negative direction, and its average velocity was 2 by t or 2 by 10 meter per second. Okay, so let us talk about speed. Let us talk about the speed. So speed is the total distance by time. There is nothing to think about the direction in speed. Speed is a scalar quantity, so it is just the total distance it covered by time. So what is the total distance? You see that when we talked about displacement, we ignored the fact that the particle had gone to 4 meter and then returned to -3 meter. We just ignored that fact. We just saw that it was initially in -1 and finally in -3, and we just subtracted and we got the answer. But so when we calculate distance, then we have to take into account what the journey of the particle means, the total length. So if you will calculate this total length, means you have to add from the here to here, then you have to go add the distance to from here to here, means this distance plus this distance, means whole backward direction distance, -1 to +4, then 4 to -3. You will calculate the distance, then I have already calculated this 12 meter, and the time is 50 or 10 seconds. So that is meter per second. Meter per second. So this is the speed of the particle. So now we know the speed, what is speed and what is average speed and average velocity. So next we will learn one of my favorite thing in this, that is the graph. I like to solve graphs, and graphs are very interesting. Okay, so now we will discuss about, as we have already we had the knowledge about what is distance, what is displacement, what is speed, what is velocity. We have all the mm, knowledge about all that. So now we will discuss about position time graph. Okay, many children face much difficulty in this, but it is very easy and very simple. This is position and it is time. So let's say this one, two, three, four, this five, nine. This straight line actually, I'm able to make it straight. It is a dotted line. It is a dotted line. Okay, this one, this part, and the horizontal line, it is dotted. It is a dotted line. Let's say 5 is here. Okay, so this is the graph of a particle, position time graph of a particle. So you have to tell me what is the initial position of the particle. You have to read this graph and tell me what is the initial position of particle, what is the final position, then you have to tell me about what is the displacement, what is the time taken, then you have to tell me what is the time taken, then you have to tell me about what is the velocity. Okay. So you may pause the video and think this, the upper one and the horizontal and this last vertical line, this all are dotted lines, and this is actual graph, the slanting line, that is the actual graph. So you may pause the video and think about the solution. Okay, so let's go to the solution. Okay, so what is our first position? What is the initial position? Okay, you may see that the particle has started from here because it is the time, it is 2 seconds actually. Here it is 2 seconds. It is 2 here. Sorry. Just this rough graph, so I'm unable to make it clear. So it is 2. So you can see that the particle started from here and it went to the last point. Okay, here. That is the meaning of the position time graph, that its initial position was here and it journeyed and covered this at 5 meters. So initial position is -5. Okay. Initially it is minus 5. If I will take the origin like this and it is a motion on straight line, so it will be here. That is this, this is the minus 5. That means towards the left of the origin. So particle is here. Okay. So like this you can visualize it. So what is the final position? So final position is it's obvious from the graph that is it is 5 meter. Okay, this is the if we will take the origin like this, then here is the final position. Means what the particle did, it went from minus 5 5 like this. Okay, you can visualize that like that. So what is the displacement? Easy. We know the initial position, we know the final position. So sorry. So it is final position minus initial position. So that is equal to 10 meter. Okay, very simple. So from this graph, you have to tell me what is the time taken. Okay, so that is the fourth question. So here it is 2 seconds and it started from t equal to 2 seconds. Okay, I have given the dotted line. That means that at initial position, that is x equal to minus 5 meter, the time was t equal to 2 seconds. And when it went to x equal to 5 meter, then the time was t equal to 5 seconds. Okay, so what is the length of time? Since from the when it covered from distance from means displaced from minus 5 to 5, what was the time taken? That is equal to 5 minus 2. Okay, hope you can understand this 5 minus 2. This is the final time. This is the final time interval. This is the final time. And this is the initial time. So this is the length of the time. So what is the time interval it covers? So if 5 minus 2 equal to 3 seconds. Okay, 3 seconds. So next we will discuss what is the velocity. It is very easy. We know the displacement, we know the time. So velocity is total displacement by total time. So it is 10 meter by 3 is equal to 10 by 3 meter per second. It is plus 10 by 3 meter per second because the displacement is plus 10. That means it has moved towards the right, and the velocity is plus 10 by 3 meter per second because means it has average velocity of 10 10 by 3 meter per second towards the right side. The plus sign indicates that it has traveled towards the right side because we have taken right as positive. Okay, so that was it for the class, and in next class it will be a little higher, and we will discuss about instantaneous velocity and speed. It's very interesting, and